Today what we're going to do is we're going to graph quadratics and cubics. With a quadratic, we're going to look at two different types, one where our a value is positive and another one where our a value is negative. An a value that's positive is going to be a quadratic that looks something similar to this, where it's going up, and a negative is where it's going down. So this right here would be where our a value is positive. This right here would be where our a value is negative. Now our vertex is going to be the center, and it's going to be in the same place as our axis of symmetry. So the axis of symmetry is an imaginary line that goes through it, and it's symmetric on both sides. Now the domain for each one of these is XER, or negative infinity to infinity, because it goes to the left and it goes to the right. The range is either, if a is positive, in this case, it would be greater than or equal to, or you could do the number comma infinity. And then if it's less than, then it's going to be y is less than or equal to, or it's going to be negative infinity to whatever number this is at. So that right there is the quadratic. Now the cubic, if it's positive, so if our a value is positive, it's going to look something similar to this right here. And if our a value is negative, it's going to look more like this, where it's going down. Our inflection point is the center of the graph. And the domain and range is really easy because the domain goes to the left and goes to the right, and the range goes up and it goes down. So it's pretty easy to figure out domain and range for cubics. So what we have is two quadratics and a cubic here. Then we're going to state the domain and range. So the first thing that we have to do is we have to decide, does it go up or down? And for this one right here, it opens up because it's positive. Our axis of symmetry is always the opposite, so that would be 3. And then our vertex would be 3, negative 1. So what we do is we take this value right here, and that tells us our vertex. Now, once we do that, what we're going to do is we're going to graph it. There's a pattern for each one of these. And when we're looking at our pattern, what we have is we start off with the vertex, which is 3, 1, 2, 3, and negative 1. That right there is our vertex. Now, if we're 1 away from the vertex, because it's a quadratic, we square it. So if we're 1 away, it goes up 1, because 1 squared is 1. And if we're 2 away, it goes up by 4. So 1, 2, it goes up by 4. And 1, 2, it goes up by 4. 1, 2, 3, 4. And that right there is our quadratic. Now, for the domain, it's really easy because it's negative infinity to infinity. And for the range, what we have is our lowest point is negative 1, and then it goes to infinity. So we're going to look at another example of a quadratic. This one right here opens down because our a value is negative. Our axis of symmetry is x is equal to negative 2, because it's always the opposite. And then our vertex is negative 2 and 2. Our k value right here, that's where we're getting our 2 from. So we have negative 2, 2. This time it's going down. So if we're 1 away, it goes down 1. And if we're 2 away, 2 squared is 4. So it goes down by 4. And that right there gives us our quadratic. Now, the cubic, our a value is positive. So it's increasing. And then what we're going to do is we're going to find our inflection point. Our inflection point is 1, -3. Inflection point is not like a vertex. It's similar, but it's the point where it changes from opens up to opens down. So we're going to plot 1, -3. And with the inflection point, since it's going up, we're going up by, notice that that's a 2. So when we go over 1, it goes up 2. And then when we go to the left 1, it goes down 2. And what we do is we try to make it as curvy. It's not a very good curved line. And so that right there is our increasing cubic.